and welcome. I've got another very interesting telescope to introduce to you, which is the Greenland Telescope, GLT, which also works in the microwave range. Again, I'm gonna first show you a little bit of history, and then the equipment, the geography, which is very special in this telescope, and then a short summary of some results, and then a summary. Microwave is in between infrared and radio range. So everything that is between 1 millimeter and 1 meter. And often these telescopes tap not only the microwave but also the sub-millimeter range, which would be extreme infrared. This telescope had its first light in December 2017, and it is kept by the Academia Sinica Institute of Astronomy and Astrophysics, which is in Taiwan, and also 3 US institutes, and later also some Danish institutes joined. It was the idea from the start to take part in very long baseline interferometry with this telescope, and this dish was kind of a leftover from the ALMA interferometer, which I introduced in an earlier video. First tests were made in New Mexico, and then they looked which parts they will keep, which parts they would modify, and which they had to replace. And there was a pre-assembly in Norfolk, Virginia. And the receiver test was at the James Clerk Maxwell Telescope in Hawaii. So it was quite a story until the telescope was could start its work in Greenland, and it is part of the Event Horizon Telescope. The equipment is shown here, so the dish looks quite similar to the ALMA dishes, but below it there's a container where people are sitting. So it still needs people to work there. It has a diameter of 15 meters, and it is a Cassegrain telescope with a surface accuracy of 14 microns. And the thing is, the telescope moves with the ground because it stands on the ice, and the ice is moving. So from time to time it has to locate itself, which it can do by looking at the sky. It's the easiest thing, easier than to measure over land. For the climate, it has to stand cold, but also heat, sun and wind. And before setting it up, especially setting up the air condition of the whole thing, they took these 3 scenarios that could happen there in Greenland. Either temperatures of -55 with quite a harsh wind speed of 13 meters per second, or even very colder temperature and even stronger winds, or relatively hot temperatures, which is 0 degrees, because then you have to cool the antenna. And it was made sure from the beginning that receivers would be compatible with ALMA. So the telescope uses a 3-cartridge receiver for 86, 230 and 345 gigahertz. The geography is really impressive. At the moment it's standing at the Thule Air Base, or also called Pituffik Base, Space Force Base these days. And where the red dot is, it's more or less at sea level and at 76 north. But the idea is actually to move it inside the ice sheet to the highest part, the summit station. But this hasn't been done yet, and it's probably not so easy. Thule Air Base is probably easier because there's more infrastructure there. The results, this result I've shown you several times with different observatories, because they all worked together to image the black holes. Actually, I read recently that one telescope should be made even in space to have a larger baseline to look more closely at black holes, especially at the inner rim of this ring. There should be a bright ring that is very small, and this can't be seen yet. So people still want to improve the EHT to be able to see that. The other thing that this telescope did is observing quasars, like the 3C216 quasar, as shown in this image here. And it also looked at the afterglow of gamma ray bursts, which is also quite a task. And here the advantage, because it's so far north, is that most of its field of view doesn't rise or set because it's so much north. So it can really make long series of measurements. That's the good thing about being so north. Or as in the South Polar Telescope, so much south. So as a summary, it is a part of the EHT. It looks at black holes and investigates gravitation and also gamma ray bursts. But I'm sure it does other things, but there haven't been so many publications I've found besides from the projects I've shown you. So it's quite impressive how this dish stands in the harsh conditions of Greenland. Thanks a lot for the attention.